Hey there, curious minds. Welcome to Plain Techniques, the place where tricky maths problems get a simple twist. Have you ever needed to figure out the length of a ramp or a ladder? Well, today we are going to unlock the secret of calculating those distances using the one and only Pythagoras Theorem. Stick around, because by the end of this video, you will have this powerful tool in your maths toolkit and solving problems like a pro. Let's go. Pythagoras Theorem. Right. Now, when you have a triangle and at the bottom you see a square, right? That means this angle is equivalent to 90 degrees. Okay? Doesn't matter what these other angles are, but if one of the angles is equals to 90 degrees, that triangle is now referred as right-angled triangle. Okay? Now, that is the first condition of a Pythagoras theorem. So, you can only apply Pythagoras theorem on right-angled triangles only. So, if you have, let's say, you have a triangle, right? So let's say this is 91, right? So this is 9, then that will be 100, and this is 80, right? So you can see that none of these angles are equals to 90 degrees, right? So therefore, we cannot use Pythagoras theorem, right? Remember, Pythagoras theorem can only be used on right-angled triangle, meaning that one of the angles of a triangle must be 90 degrees. Okay, let's continue. Let's take a real-life situation. Let's say this is your garage. This is the ramp, right? So these are the bricks, right? So this is the foundation, okay? And then this is the door for the garage, okay? That is the door. So that's the ramp, and then here is your vehicle. All right. Okay, so you are going that direction. Okay, now let's say you know the height. This is 90 degrees, right? That is 90 degrees. You know the height of that wall. Okay, and you know, let's say this is why you know the length of your ramp, right? Now we want to calculate what will be the length of that ramp. Okay, how will you go about that? Okay, so you can only use Pythagoras theorem. All right, we want to label our triangle. Okay, let's say you have a triangle like that, and this is 90 degrees. Okay, the objective is to identify all these three sides. Right, the first part that I'm going to do is to explain how to find the hypotenuse. Right, let's take a step back. What is a hypotenuse? A hypotenuse is the longest side of the triangle, right? And how do you identify that longest side? You look at that 90 degrees sign, right? Where it's pointing. So this is what I'm going to do. This is where that 90 degrees is pointing, right? It's always pointing towards the hypotenuse. Okay, so that means this side is my hypotenuse. Okay, let's flip that triangle. Okay, let's say you have something like this. Okay, and this is my 90 degrees. Okay, so that is my 90 degrees. Now, look at that. This is my 90 degrees and it's pointing this direction. Okay, now what does it mean? This means that this is now my hypotenuse. Okay, I'm going to call this my hypotenuse. All right, now take a moment, right, and tell me which one will be your hypotenuse if you have this. Okay, all right, let's resume. You can see that this is your 90 degrees. Okay, so this is my 90 degrees, right? And it's pointing that direction. Okay, what does it mean? This will be my hypotenuse. Okay, all right, so we are still continuing with how to label a triangle. Okay, now let's say you are given a triangle, a right angle triangle, A, B, C, right? How would you name this side, right? How would you name this side and how would you name that side? All right. Now, let's say for this side, you can say AB. All right. So this side can be called AB. I'm going to put it in green. That side in green, it's A, B, or it can be named. You see here, this side is opposite letter B, right? So you can say a small letter or a lowercase of that letter, whatever letter that is opposite that side, all right? So the letter that is opposite this side is capital letter B, meaning this side can also be called small letter or lowercase b. Okay, that is what I'm going to do, lowercase b. Okay, now what would you call this side? Let me put that in red. So this is in red. What would you say this side is? The name of this side? I would say BC. Okay, so it's either B, C, or look at that. The name, right, is BC, and this side is opposite which alphabet? It's opposite alphabet A, capital letter A. Okay, now what do you do in this case? You take the lower case or a small letter of that capital letter, okay, and put it here, right? So that means this side will be called a small letter A. Okay, now the last one, you can pause and tell me what would you name this side. Okay, so what I'll do is I'll say this name is AB, or look at that, it's opposite. This side is opposite which alphabet? It's opposite alphabet capital C. Okay, right, therefore I can call this side small letter c or a lowercase c. So this is a small letter c. All right, So what I'm going to do is I'm going to remove these other ones. Okay, I'm going to remove those other ones. Now, if you check, right, this side is now a, small letter a. The whole of the side is small letter a, and then the whole of that side is small letter b, and then the whole of this side is small letter c. Okay, so from the previous slide, we did establish that if you are given a right-angled triangle A, B, and C, right, you will end up with small letter A, small letter C, and small letter B. I'm going to go ahead and remove these ones. All right. This is what is remaining, right? Now, from that, how would you apply Pythagoras theorem? Remember, the longest side opposite to your 90 degrees. This is now called hypotenuse. Okay, so you take hypotenuse side, which is B. Okay, so that is hypotenuse, which is B, and you put squared. So hypotenuse will always equals to A squared plus C squared. Okay, so what I'll do is I'll go ahead and say A squared plus C squared. All right, now, so that is the Pythagoras theorem. All right, now let's say you are given a triangle this is triangle R X Y. All right, this is R X Y. Right, the first thing that you need to do is to be able to identify your hypotenuse. All right, now take a moment and identify a hypotenuse. Right, let's continue. This is my hypotenuse. Right, this side is my hypotenuse. Why am I saying that? This is the longest side of the triangle and its opposite 90 degrees, right? And the name of that side is now called R. Okay, remember, your Pythagoras theorem says you take the hypotenuse and you put squared. Let's put that into writing. So you take hypotenuse squared, which will be equals to the other two sides squared. Okay, so the other side is x, so I'm going to go ahead and say x squared plus y squared. So that x is that one squared plus y is that y squared. All right, this is now your Pythagoras theorem. All right, now let's try to do some examples. We have example number 1, 2, and 3. So we are going to go through all of them, right? Now, the question says, calculate the missing sides. So we know here, H is the missing side because it does not have the value. And then G is the missing side for example number 2 because it does not have the value. And then for example number 3, F is the missing side because it does not have the value. We want to know what is the value of that side. All right. Now, let's start with example number 1. The first thing that you need to ask yourself is this a right-angled triangle? Yes, this is a right-angled triangle, right? Why? Because one of the angles is equals to 90 degrees. Okay? Great. The second part means that you can apply Pythagoras because you have a right-angled triangle. Now, if you have a right-angled triangle and you need to calculate one of the sides, what do you need? You need to put down the Pythagoras Theorem equation, okay? So for you to be able to write or put down the Pythagoras Theorem equation, you need to know or identify hypotenuse. In this case, hypotenuse will be the longest side and the side that is opposite 90 degrees. So hypotenuse will be h, all right? So let's go ahead and put down the Pythagoras equation. So it's hypotenuse squared plus the rest of the sides. F2 plus G2. All right. Now, where you see F, right, you put 3, right? So I'm going to have 3 squared. Okay? And then where you see G, you put 4. All right? Therefore, I am going to have 4 squared. Now I'm going to go ahead and calculate all of this, right? So this will give me 9 and this will give me 16, okay? So remember this side to still have h squared, h squared, h squared. Okay, so this will be 25 when you add them together. So it's 25. All right, so what I'll do is to get h, I'll put square root on both sides, right? And this side I'll still have h, and this side I'll have 5, all right? Which means h is equals to 5, all right? So h will be equals to 5. Now let's move to the next one, right? So on the next one, what do? We need to know, is this a right-angled triangle? Correct. This is a right-angled triangle, right? That means you can apply Pythagoras theorem, okay? Now, for you to be able to apply Pythagoras theorem, you need to be able to identify h. H meaning hypotenuse, okay? So what is the hypotenuse for this side, or for this triangle, sorry? Hypotenuse is the longest side and the side that is opposite 90 degrees, you see? Opposite 90 degrees. So in this case, hypotenuse will be h, right? So Pythagoras theorem is hypotenuse squared plus the rest of the sides. So g squared plus f squared. All right. Now, what do we know? We know that h is 5, so I'm going to put 5 in place of h. This is what I'll do. And therefore, I don't have g. I'm going to put it like that. And what do I have? F. F is 3. F is 3. So where I see F, I'll put 3. All right? So I'm going to go ahead and put 3. Okay. So I'm going to go ahead and simplify. This will be 25. This will be g squared. And this will be 9. All right? So I'm going to take 9 to the other side. All right? So that will be 25 minus 9, and then g squared. Okay? So 25 minus 9, which is 16. So this side I still have g squared. So I'm going to say g squared 16. So I just swap them. All right? What I'll do here, put the square root sign on both sides. This side I'll be left with g, and this side I'll be left with 4. Okay? That means g equals to 4. Okay? Now let's move to the last one. Okay. So on the last one, what do we know? We know that this is a right angle triangle because of what? Because of 90 degrees. Right. And that means we can apply Pythagoras theorem. Okay, so if we can apply Pythagoras theorem, we need to identify hypotenuse. Please pause the video. Let me know which one is hypotenuse. All right? Okay, now let's continue. This side is the hypotenuse. And the reason for that is because it's opposite 90 degrees here. All right? So it's opposite 90 degrees. So your Pythagoras equation will now be hypotenuse squared plus the rest of the sides, f squared plus g squared. All right? So hypotenuse, which is h, if your hypotenuse was f, you would have f here, right? Squared, and then the rest of the sides. Okay, great. Now let's substitute what we already know. We know that we know that h is 5. We do not know what f is, but we know g is 4. Okay, so this will be 25, and then this will be f squared, and this will be 16. Okay, so 25, I'm going to take 16 to the other side. All right, so that will be 16 minus 16 f squared. Okay, so 25 minus 16, which is 9, f squared. So I'm going to say f squared equals to 9. So I just swap these two, right, which is the same thing, right? What I'll do here is I'll put square root. All right, so I'll have f, and this side I'll have 3. All right, that means f is equals to 3. All right, so if you have watched up until this far, I really appreciate it. Thank you for watching, and don't forget to like and subscribe. I'll see you on the next one. Ciao.